Alright, we're going to be looking at how to balance chemical equations, and there are some things we need to know. Some of them are going to be review about some states of matter and things that we're going to see in our chemical equations. Okay. State of matter is also called a phase of matter. We're talking solid, liquid, gas. So a solid, we're going to use a lowercase s in parentheses in order to talk about solid. You could talk about the solid being a precipitate, or crystal, and we're going to see definite shape and volume here. A liquid is going to be pure, meaning it's not a mixture. So when we have solutions, we're going to have something else that we write. And here we have a definite volume, but an indefinite shape. Our gas, we're going to use a G. Again, I use up above, I used a cursive L so that you don't think it's a 1. Gas is a G, and it is also a pure substance. And so we're going to see that it has an indefinite volume and shape. Plasma is our third state of, or our fourth state of matter. However, we don't really typically see plasma on the Earth, and definitely not in our chemical reactions, because it's really highly energetic and excited gas. So it's like beyond gas, if you will, and it's just really high temperature, and so we're not going to see that. But aqueous, AQ, if you recall, we've talked about aqueous or aqueous. We talked about aqueous solutions. These are homogeneous liquid mixtures with water as the solvent. They are going to be clear. They may not be colorless, because depending on the solute we put in, it may in fact be may have a color. Like iron solutions are going to be orangish red, copper solutions are going to be turquoisey and bluish, and then some things just have no color. Alright, so we're going to start seeing these in our reactions. What do equations show us? They're going to express a chemical change. We can use them to express physical changes, but usually it's going to be for chemical changes. That means we're still going to have the same elements that we had before as what we have after, but according to Dalton, and it still holds true today, we're just going to rearrange how those atoms attach, okay? So they're going to show us what we have before the change and after. This sounds pretty familiar, right? What I have before should add up to equal what I have after. Okay? Now usually we say reactants, yielding products. And I want you to take a look right here. My arrow is different. Key is the arrow doesn't always have to point to the right, but it does always have to point to the products. Okay, so notice that the arrow always points away from the reactants and it always points to the products. Well, why do we need to balance our equations or make things equal? Well, we've got to obey the law of conservation of mass and the law of conservation of matter. So, matter can't be created. Well, I'm just trying to say everything in one word. Be created or destroyed. And so what that means for us in a chemical change I need the same number of each element before and after. So on the reactant and on the product side. So there are going to be different types of equations that we see. Skeleton equations are going to show the formulas, the chemical formulas, so the chemical symbols for all compounds and elements, but it does not keep the law of conservation of mass. So we say that this is unbalanced. It's just going to tell you what we're making. It's not going to talk about how much or in what ratio. The molecular or balanced equation is going to show the formulas for all compounds, but it is going to illustrate the law of conservation. That means equal numbers of each element before and after. Alright, so I want to make sure we understand what I mean by equation and reaction. Okay, so an equation is going to have, they're both going to have arrows. Okay, it's going to always be reactants going to products. They are going to do this. Okay, the equation is usually going to talk about it's going to give you the reactants and the products. And products given. Okay. In contrast, the chemical reaction is going to talk about how, or the process happening. Okay, a lot of times on reaction, I'm going to ask you what type of reaction. Like, what is really going on? Like, we can have a single replacement, a double replacement, hydrocarbon combustion. You can have a redox reaction or an acid-base reaction. It's talking about, okay, I have these two reactants, and I'm going to mix them together, and you have to tell me what the products are. Okay? When we talk about an equation, there are different ways we can express those reactants and products. So when I ask about a chemical equation, I'm talking about, is it going to be a skeleton or a molecular? And so it's going to talk about different ways to show those reactants and products. Okay? So we're going to look at some hints for balancing, and then we're actually going to balance a little bit. So you're never going to change a subscript. Once that formula is written, you cannot change it. You have to leave it alone. But what we can do is use coefficients in front of the compound. Again, the coefficients are those numbers out in front. I can play around with those a little bit to try to make things balanced. I can't change what that substance is. I can't change how many oxygens I have in it. I can't have sulfate with SO4 and then magically change it to SO3 sulfite. That doesn't happen, okay? But I can put coefficients out in front of the compounds. Okay? And we're never going to put them in the middle of the compound. They always have to go out in front of the actual compound. So we can put them in front of things that have a plus sign in front of it or a yields arrow, but we cannot put it in the middle. Okay? So for example, if I have H2O, I could put a 2 out in front, but I cannot say H2O and put another 2 in the middle. Can't do that. I can do that. Balance everything except for oxygen and hydrogen first. Notice these, it doesn't say rules, it says hints. But typically if you do oxygen and hydrogen first, then you're going to have to go back and rebalance time and time again. But if you wait and do oxygen and hydrogen last, then they tend to balance themselves out. So after we do everything but oxygen and hydrogen, then we tend to do hydrogen, and then we do oxygen. You can keep the polyatomic ions together, and if all the coefficients have a common factor, reduce them all. But if you reduce one, you have to reduce them all. And if you get stuck, start over and try out a 2. The other thing is expect to erase. Because that's just the way things happen. Think of it like a teeter-totter or a seesaw. Like, it's going to take going back and forth a little bit before you can actually even it out, okay? And so same thing's going to be true here. I'm going to show you a couple methods to do this, but I'm going to grab a pencil here real quick. And I'm going to show you the way we need to end up being able to do this and do it quickly, and that's by inspection, okay? And so we're going to kind of keep a mental tally of how many I have on each side. Again, this is like our fulcrum here, our pivot point, our before and our after, and remember that whatever elements I see on this side have to add up to equal the elements on that side, okay? And so let's take a look. Step number 1, it says balance everything except for oxygen and hydrogen first. Well, I don't see anything other than hydrogen and oxygen. So step number 2 says to balance hydrogens. Well, on this side I have 2 hydrogens. On this side I have 2 hydrogens. Again, 1 times 2 times 1 for no parentheses. So that's 2. On this side I have 1 times 2 is 2 times 1, no parentheses. So that's going to be 2 and 2. So they seem balanced. Next, let's go out here. I see 1 times 2 times no parentheses 1. So 2 oxygens on this side, 1 times 1, no subscript, times 1. So I've got 2 on this side, 1 oxygen on this side. What's the least common multiple between 2 and 1? Well, 2. So that means I need to make sure I have 2 on this side. So 1 times 2 gives me 2. And on this side, what number times 1 gives me 2? Well, 2. 2 times 1 gives me 2 now. Well, let's go back. Let's check our hydrogens. This side I have 2 hydrogens, but on this side now I have 2 times 2 is 4 times 1. So I've got 4 on this side, but only 2 on this side. What number can I put out in front to multiply by to get 4 hydrogens? What times 2 gives me 4? Well, a 2. And so our coefficients would be 2, 1, 2. You do not have to write the ones, and in fact, we'll get to the point where we don't. But a lot of times on our homework, I'll have like a little table off to the side that has boxes, and that's just to help me grade things a little bit faster. And so we would say 2, coefficient of 2, 1, 2. Okay? Let's try one more example, and then we're going to do a whole lot in class, okay? On this next page, here's another one. Let's do number 3, okay? So we're going to skip number 2 and go on to number 3. I'm going to balance things that aren't oxygen and aren't hydrogen. Again, I usually work left to right, and if it's oxygen, I just skip over it. But here I have 1 potassium. On this side, I have 2. So I need to make sure I have 2 on both sides. So I'm going to put a coefficient of 2 out in front. 2 times 1 is 2. And then here I've got 1 times 2 is 2. I have borons. I have 1 times 2 borons on this side, no parentheses, and only 1 on this side. So 1 times 2 is 2. 2 times 1 is 2, and my borons are balanced. Now, if I look here, I have 1 times 3 is 3 oxygens, so I have 3 oxygens on this side. On this side, I have 1 times 1. I only have 1. Ooh. Remember I said get ready to erase, so I'm going to have to change this one to balance out the oxygens. And in order to change that, I'm going to have to put a 3 out in front. And so now my oxygens are balanced. But what did I just unbalance? Remember we went like this. I have 2 Ks And now I have 3 times 2, 6Ks. So I can erase that coefficient out in front, and now instead of saying 2Ks, I need to say 3 times 2 is 6Ks. So I have 6 potassiums. 3 times 2 is 6 potassium. 1 times 2 is 2 boron, 2 boron, 3 oxygen, 3 oxygen. So I'm balanced out. And what I would do for my coefficients, 1, 2, 3, 4, I'd do 6, 1, 3, 2. Alright, we're going to try some more tomorrow. If you have questions about these, please write down your questions right here about 1 and 3, because I want to go back over those, any questions that you may have. I'll show you an alternate way of, it's not really an alternate way, it's just writing down our work every time, which is good for some people at the beginning, but it gets to be too much. We've got to build this skill and get it to be pretty fast for us, okay? But we'll balance some more in class.